Merhaba arkadaşlar. Yüzde olarak yani hak yok, öyle bir hak yok da dönem sonunda bakacağız şeye. Okay, so we were talking about arrays and specifically multidimensional arrays, and we had the two examples, the 2D array example, which basically, you know, we were writing these two-dimensional array elements on the screen, and then the other one was soda survey, so I will go over those two examples again. Let's open that up. So in the 2D array example, what we have seen was we had a two nested loop, two for loops nested in one another, and then we basically what we were doing was, if you remember, we were loading the values to the array elements, which was a two-dimensional array, int array with 2 dimensions, and we had 5 elements on the row and 10 elements on the column, and for each row and column we were assigning the corresponding entry of the array to the specific value, that's row multiplied by 10 plus the column, which gives you, for each row you start with number 0, right, and then you go 1, 2, and then 9, and you go on to the next row when your row is, this is row 0, and then I have row equals 1. In that case I'll just multiply my row number, which is 1, with 10, and then add the column number, which will give me the numbers that will range from 10, 11, and then all the way to 19. And this will go all the way to row equals 4, which will be the length of the table, right? Why is it 4? Because I get the table dot length, which gives me the first dimension, the size of the array's first dimension, which is 5, so I will go all the way up to row 4, in which case I will multiply by 10, and for row 4 I will have 40, 41, and then all the way to 49. This was what this code was actually loading into the array elements. Then we were printing all these values one after the other one, right? This was the example we just saw in the previous lecture. And if you go into the soda survey example, so basically, let me execute this. So we had the soda values averaged over all the persons. Remember, there were 4 sodas, and then each person gave a score out of 5 for each soda that they tasted. So what they did was, you know, they give these scores, and then we get the average of all those sodas. So you get soda 1 through 4, and then for each person you also get the average of that person's specific, you know, scores. So this lists them in this fashion. What if I would like to write these in a nicer table instead of this? How can I write that? So what I mean is, if instead of this way, if I would like to write this such that I have this table printed on the screen. For each soda, I will have soda number 1, soda number 2, soda number 3, and then soda number 4. And similarly, I will have the grade that is given by each person. So I will have P1, P2, and then all the way to P10. And at the same time, I'd like to have an average, which indicates these averages listed at the bottom as a separate line or row. And then I'd like to have the averages for each soda printed as a separate column at the end. So how can I print this on the screen? Not storing anywhere, but I just want to see it on the screen as instead of this one shows it one after the other one in a tabular form, I'd like to have it in this fashion. How am I going to write that? So going back to the code we have here, if you remember, these are the scores that are initially given to each soda. So these curly brackets indicate the scores for soda 1, and then you have the soda 2 scores, soda 3 scores, and then soda 4 scores for each person, person 1, 2, and then so on, person 1, 2, and so on. So this indicates what the values are initially initially will be. And this is indicating the number of elements you have. So final int sodas, the number of sodas you have, scores.length. So it's going to give me the size of the, which dimension? The first dimension, which is row basically. So whenever you say scores.length, you'll get the number of rows. So I have one element here, the second one, third one, and then fourth one. So I have 4 sodas. And then if I say scores 0.length, what I mean is this array. This array, so how many elements in this array? 10 elements. So that means there are 10 people that I'm going to print the grades or scores for. So again, if you remember the array representation, so we have, in this case, the scores array is something like this, right? So I have an array that points to an array of integers, which basically points to these individual integer arrays, right? So whenever I say scores 0, I actually mean this element, which is actually an integer array with 10 elements. So whenever I say scores.length, what I actually get is this array's size, which is 4. Whenever I say scores 0.length, then in that case I access this array, which is of size 10. Okay? So just a reminder. And if I want to print it in this fashion, these are the constant values, the number of sodas and the number of people who gave these scores for. And as you see, to get the averages for each soda and for each person, what they have done is that you have the soda sum. Why do I have an array here? Because I have more than one soda, right? I have 4 sodas, so for each soda, I need to get the sum of the scores for each soda. So I will have an integer array, which is going to be basically with 4 elements. And then I will have a person sum, which adds up the scores given by a specific person. In that case, I will have as many number of people as I have in the array. So that's going to be the integer array for person sum. And once I get those, if you look into the computation, how do you compute these values? Basically, you need to go over each entry one by one, and then add these up to get the soda sum. And then add these up to get the soda sum, and so on. For each person, what you have to do is that you will have to add these up to get the person sums, right? So I will have to add for P1, whatever the scores, I will need to add those up in order to get the sum of that specific person's total. So to do that, what you do, you have a, again, doubly nested for loop, where you have 4 int soda 0 and then soda less than sodas. So I have 4 soda. I'll start with 0 and go all the way to 4. And then for each person, I will start with 0 and then go all the way to number of people, so which is going to go up to 9 as the last element. And soda sum soda, so I will increment my soda sum every time I get the scores for soda person. So I get that specific value for this soda and add that to the soda sum of my current soda. So it's going to add all these up for this specific soda, and then you'll get the soda sum for this, for this specific soda. So what does it do? After that, it basically prints out the soda, right? It prints out the soda number, and then you have the soda plus 1. Why did we have the parentheses here? Otherwise, what would happen? It is going to concatenate this soda and then will concatenate one afterwards. So to prevent that, we added parentheses to first perform the arithmetic addition, soda plus 1, and then concatenate afterwards. Right? So what does it do? It prints the soda results and then person results. So this is the initial application. What if I would like to modify this such that I print it in a tabular fashion like this one? So how are we going to modify? We can basically use this value. So let's first list the elements of this array one. First print this part initially. So this part, let's say. So how am I going to print this part? I will basically have this again, the two nested loops, soda and person, and I will print, what am I going to print here? So I will say, I will copy this. I will system out print, since I don't want to go into the next line until I finish the whole line, right? I will have print. And then what will I do? I will have soda. No, not soda, but what's the array? Scores. Right? Scores, and then I will have the corresponding soda and the corresponding person. So this will basically print me the corresponding. So let's add a space afterwards. So basically what this will do is that I will print the score for that specific soda and person on the line, and then go on to the next element and so on. So whenever I'm done with the first soda, what do I need to do? I will need to add a print line statement to go into the next line, right? So what will I do here is that in here I will add another print line just to print a print line statement at the end, right? So if I compile and execute this, as you can see, I have the table printed on the top with each row, and on each column the scores are printed. Now what do I need to do next? I need to get the corresponding value of the, right? Value of the soda at the end of the line. So where do I need to put that? If you go into the code, where should I write that? Right before I go into the next line, right? I need to print that value before going into the next line. So which should be before this point. Once I print all the person scores, I will print that value afterwards. Right? So how am I going to print that? So I can join it with this one. And I will have, you can just copy the value from here. So I will and then so this is going to basically print the soda average for that specific row. So let's add a tab before that, so that makes I need to move this formatting before, so that it doesn't give me any errors. Right? So basically what I did is, instead of the print line, I just added the average, and after that I print line and go into the next line. Hopefully this compiles correctly. As you can see, now I have the values printed, and then afterwards with a tab I have the average of the scores for this specific soda. And what do I do? Next, I would like to have a separate row which prints the averages for each person. How am I going to do that? How should I embed and modify my code to do that? Exactly. Once I'm done with the whole loop, which does the rows and columns one after the other one, I can have a separate for loop which is going to basically start with the person 1 and go all the way to the last person to print their values. So basically what I will have is that I'll just copy this for loop and then get rid of the rest. So I have this for loop, which is basically going to print me the values. So in this case what I will do, I can copy this system.print line, and I will print with space in between. I'll copy this. So what was the value we had? Person sum, right? person some soda. So what do I need to divide that with? I will need to divide it with the number of sodas, so that I'll divide it with 4 and get the average value for a specific person. Soda, and then I'll just add a space. And that should do it. Okay, yes, this should be person. Cannot find symbol sodas. Okay. Okay. So averages are printed at the end. Obviously, you may want to add tabs to align them correctly if you want to do that. Okay, any question? So basically what you have to think about is that you have to understand the problem and then use the loops according to your specific needs. And you will definitely have questions in the exam that's going to deal with loops and to write loops using arrays as well. So I strongly recommend you to do practice if you haven't done yet. And if you have if you want to see the length of each dimension, size of each dimension, you can use the length constant of that specific dimension, such as the one that we did with scores 0.length. This indicates the the second dimension's size. And if you have, for example, an array that is 3-dimensional, and you have 3 dimensions on the array, then what you need to do is to find out the size of this dimension. You could basically access scores 0 and then let's say 0 and then length. So this will give you the corresponding dimensions, size, how many entries you have in that dimension in the array. So basically you could use the length parameter to access those. And if you have if you have arrays that have different sizes of dimension, for example, let's say I have this one. Remember, I had this scores with 4 rows and 10 columns on each. What if I'd like to have an array that is going to have an element with 10 elements for the first part, and then you have 5 elements here, and then another 10 here, and then 20 here. You can write this kind of array and initialize them, but this is called a ragged array, and you can do that by specifically initializing this array and then assigning it to scores 0 and so on. So you have to go one by one in order to be able to write such a ragged array implementation, right? So I will create this array first in 1 dimension with 10 elements, 5 elements in 1 dimension, and 10 elements, 20 elements in 1 dimension. And then for each elements of these scores, I will assign it to this created set of arrays. Okay, that's called ragged arrays. And in CS 101 we have covered. If you don't remember or don't understand, you can go back and check the contents from the CS 101 and remember that part too. Arraylist class is also something you have seen before. So it's basically an easier implementation of the arrays. So what you do in Arraylist is, if you remember, so what does Arraylist provide? Let me ask you that first. I mean, what basically is provided by Arraylist? Why do I use Arraylist?
Size can be extended.
Exactly. So if you don't want to, if you don't want to have a fixed size of an array and you want it to expand as you add more elements, that's where you would like to use Arraylist. Obviously, in Arraylist you have an internal implementation that is performed by an array. So in an Arraylist you have, let's say you have an array list of integers. You basically have an array of integers which is initially set to a certain size, and then every time you add and you get to a certain limit, it is expanded basically by doubling the size, as we did with the increase size method that we had before with the array. So basically it increases as you add more elements, and so it provides nice methods to make life easier for the programmer. So basically that's exactly using the same underlying implementation, but rather giving you more opportunities to write a better code. So as you add, elements to the array list, what happens is that it basically adds the element towards the end. So once you add an element onto your array, for example, add an integer, you always add it to the end, unless if you specify a specific location to add the element for. So, for example, if you would like to add your element in a location such that, if I have an array list that stores these values, what happens if I would like to add the element right exactly here? So what's going to happen? Basically, I need a room here, right? So I need to make a room first, and then I can add the item to that specific location. So what's going to happen is that, let's say, this is going to move to the next one. This one will move here. This one will move here. And then I will have this empty location, which then I can add the element that I'd like to add here. So as you can see, it causes a lot of overhead in shrinking and enlarging the array if you want to add in a location that is not at the end, or if you delete from the end. So that's going to create problems if you remove this element from this location. Also, you need to move things back, right? So you have to copy everything back to the previous location, such that you shrink it back to its normal size. So you have to collapse, and also you have to make room for the added element. So this is the overhead or extra effort that you need to pay. However, if you're adding and removing from the end, this is always easy to implement. So you basically add and remove from the end, and that will be just easy to perform. So you adjust the indexes accordingly based on the movements or additions or removals from your array list. So let's see the example Beatles.java. So as you see, you have array list band, new array list, and then band add Paul and band add Pete, John, George, and all these will be added. It is going to create an array list of strings, since you have these arguments added as strings, and it's going to create that array list for you. And then whenever you say print the band, it's going to basically go over all the array list elements and call their toString methods one after the other one. Okay, and you can get the location of a certain array list element by calling, band index of Pete. So it's going to get the index of this band Pete, which is basically 1, and then it's going to call this method band remove, and then given as 1 will remove this Pete, so that the new one will be Paul, John, followed by George. And then if you add Ringo to the second position, it's going to add this band there, and then we'll update the new band, and you can print that. You can print that at the end according to the changes. So let's compile and execute this. So as you see, this is Paul, Pete, John, George, and then it gets the Pete's location and removes it, and then you get Paul, John, and George. And then what next happens is that at index 1 you have the John. However, it is adding this new element Ringo into location 2, which is going to insert Ringo here, and then George will be moved to the next position, and the new size of the band is equal to 4, and that's done all with array list operations. So if you go back to the array list operations, we have the index of, which gives the first index that is found in the array list, right? If I want to get the last index, is there a method to do that? Last index of method will return you the last appearance of Pete if there's more than 1. If there's 1, obviously index of and last index of will return the same thing. And you can remove with a given integer location in the array list, and then you can add for a given specific position. What's going to happen if I just change this to be band to Ringo? It's going to add it to the end, right? It's not going to go into the second position, but the last position, which is 3 in this case. So band size will return you the number of elements you have in your array list. So it's going to return the number of elements in the array list. So this is a basic example which shows how array lists are used. And again, you have seen array lists in CS 101. This is just a reminder. When you implement objects with array lists, you can also do that, such as this one. So you create a list of family elements, which is array list family of type family, and then you have a reunion, and it's going to create an array list again with the type family. So you can have here string, int, object, any type that you have in mind, you can do that. These array lists are really useful in actually generics, which will be part of chapter 12. I don't know how much it will be covered here, but it's a lot more useful in generics implementation, which provides type of classes which you can use it in any type or in any data type. It could be primitive data types or objects. You can use that kind of classes for. So, but for now, we will not go into the generics. It's not part of our course. So, as again, array list class is implemented using an underlying array, and then it is manipulated to adjust the indexes. So you have a lot of copy operations, and as elements are inserted and removed from the front or the middle of the list, the remaining elements are shifted. So you need to shift everything, as I said earlier, back or to the front in order to adjust the spaces and perform the alignment. So when you look into arrays and loops, they're really useful in also graphical objects. So this is the next part of this chapter, which is basically going to use these components, polygons and polylines. So you can draw things according to these graphical components based on the object's locations, such as the polygons and polylines. So we have in Polygon, you provide the points for a given shape. Basically, you provide x and y dimensions, and it draws this polygon based on the dots you have. So every dot here is composed of an x and y coordinate. What you do is that you give the x coordinate as an array, and then y coordinate as another array, and then you mention how many of these array elements you would like to use. Let's say n, so that you paint the polygon on the screen. So let's see the rocket.java example. This is a nice figure. So basically what you see is here that you have a polygon, right? This is the first polygon with the coordinates. All these are the coordinates of the polygon, the outside one. And then you have an inner polygon like this one with a different color. And then you have a polyline, which basically, again, you have the coordinates of the xy, xy coordinates. And then it just prints the polyline by connecting the dots one after the other one. So if you go into the code, this is the rocket.java. So let's open up the rocket panel. So as you see, these are given initially as x rocket array, integer array with the coordinates, and then y rocket, which gives the rockets, y coordinates, and then you have the x window and y window, which is the smaller, polygon in the middle, and you have the flame, which is basically the polyline at the end. So once you have these coordinates, it's very easy to come up with the, drawing on the screen. So you have the constructor with background black, and then the dimension 200 by 200, and the paint component, which basically will be painted on the screen once it is called. It is going to first call the JPanels paint method, and it's going to paint the corresponding things, and then on top of that, it's going to paint the outer, polygon, and then you have the page fill polygon. the x dimensions on an array, and then y dimensions on an integer array again, and then you give the number of elements you would like to plot on the screen, which is given by the length of the x rocket. Obviously, you could choose to just print 3 of those coordinates as well. It's up to the designer or up to you to select how many of those array elements you would like to paint on the screen. Okay? It doesn't have to be all of them, painted on the screen. So you could just choose 3 for this specific example. So if I choose, for example, 4, what's going to happen? As you see, it just chose those first, points that are part of the list, and then that's about it. That's going to be painted on the screen. Okay, so this is the first point, this is the second point, and then this is the third point, this is the fourth point. Okay? So basically what it did was, so you have the first point, and then the second point, and then the third point, and where does the fourth point? So this is the fourth point, for example. So what it does is that it combines these dots, and then the first and the last dot is also combined to make it a polygon. So whatever is inside these things is painted as a polygon. If I change it to, just to play around, if you change it to 6, basically it's going to add more points. And then in this case, it used those 6 points, 1, 2, 3, 4, 5, and then 6, and then combine the first and the sixth point. So you can choose how many points you would like to have there. And again, you have the filled polygon, which is going to be a filled polygon with the x coordinates and y coordinates given with these integer arrays, and the number of entries you would like to plot on the screen. And then you have the new color that's set to red for the flame at the bottom. And you have a draw polyline, which is going to basically go over all the x and y coordinates one after the other one. So in this case, it will start with this and then go like that. And then we'll finish at the end point. That's going to be the polyline that you can draw. Okay? Any question? This is just a frame that you call the panel, create the panel, and then use that panel on the frame. So I didn't go over this because, this is the same usual stuff that we have been doing. You create the frame with the title rocket, and then indicate what action is going to be performed once it's closed. And then you create a panel, which is basically the rocket panel which I just shown. And this is going to be added to your frame with the add panel method. And once it's added, you will set the size of the frame based on the panels added there and show it on the screen. Any question? So you could also use, overloaded draw polygon and fill polygon methods, which take a single polygon object as a parameter instead of, coordinates. You can give the polygon objects as well, which could be used. Basically, polygon object is also composed of x and y coordinates, which is going to, map to the same exact implementation. It's part of the abstract windowing toolkit, and then you can, use these with the given library. The next thing that we are going to cover is the mouse events and key events. So this is going to be the last part of this chapter. So, as we have seen before, we have seen the, button clicks and button events. In this part, we will cover the mouse events. So the specific events which you are already familiar with, mouse pressed. So this is going to happen when the mouse is pressed down. Mouse released when when you release the mouse button. And then mouse clicked. The mouse button is pressed down and released without moving the mouse in between. So it's just click and then release afterwards. So that's called mouse clicked. And then mouse entered, basically it means when your mouse pointer enters, you know, on a window, for example. Whenever you move it, it comes on top of that specific window that you have. So that's mouse entered. And then mouse exited, the mouse pointer is moved off of a component. So you move it out of the box of a given component, such as let's say a panel. If you move it out of that area, then that's going to be mouse exited. We have motion events as well. So mouse moved, whenever the mouse is moved from one location to the other one, or mouse dragged, you know, whenever you click and then move your mouse is going to be mouse dragged, right? So that's what drag means. The mouse is moved while the mouse button is pressed down. So these are the events, mouse events or mouse motion events, which are captured by the listeners, such as mouse listener and then mouse motion listener. If you want to perform a certain task based on mouse movements or mouse clicks, you have to implement these interfaces, mouse listener and then mouse motion listener, whichever you need to. So these are going to be related to mouse motions, such as move and drag, and then listener is the previous four, you know, events that we have listed: click, and then release. What else was there? Pressed, and then entered, right? Exit and enter. So you use, as we did with the item event or, you know, button event, we use mouse event object to you know, indicate this event actually happening in the implementation. So mouse events, let's see this dots.java example, and we will see the details of it now. So this is basically the application. So whenever I click, it creates this yellow circle and then green circle, sorry. And then I have this, you know, circles added onto the panel as I click more and more. As you see, I have the counter which keeps track of the number of, you know, clicks I made so far and then their specific locations. So what do you think I need to implement here in order to be able to see this kind of behavior? So I need to check the mouse click event. So at every mouse click event, what do I need to do? I will have the counter updated by 1, incremented by 1, and at the same time, I will need to, you know, paint it on the screen. So if you remember, the paint component basically is going to be called with every, you know, refresh I have. So I need to keep track of all the points that have been painted before or clicked before. So to do that, you have to keep track of their locations when they have first, you know, clicked at the beginning. Because you will call the repaint method, which is going to basically call the paint component method over again. So you have to know the points in order to put their into their correct locations, as you did whenever you click them. So let's go and see the implementation. So this is basically the frame. It's basically not going to do anything because, you know, nothing has been implemented for dragging or moving or, you know, these other, you know, options. It only cares about the mouse click.
Hocam şey yaptığınız, bir kere klik ettiğiniz dimension'ları tekrar klik ettiğinizde ne olur? Belli bir x yani.
It's basically going to add another point to that specific location. It doesn't care about the, so I'm adding, you know, I'm not moving the dot at all. I'm just clicking. So it doesn't care about this point is being pressed before or not. What it cares is that it keeps track of the last dot that is pressed and then adds it to the, basically, the end of the array list. However, if you want to do that, you could just compare it with the all previous dots and then just check whether it exists already and then not add it to the array list. That's possible, but you have to do a separate operation in order to do that. So if you go here, dots panel.java. So as you see, you have the array list which is used here, and then you have an int size 6, which is basically the size of the circle that we are printing on the screen for each dot. And then we have an array list point list. Point is basically a type that is available in the AWT, again, Abstract Windowing Toolkit, which basically indicates the coordinates in a two-dimensional screen, which is composed of x and y integer values. Okay, so you can get points x coordinate and y coordinate by dot x and dot y and easily access them, as we will see shortly. And this is the list of points that you have in your implementation, in your panel. So basically, whenever you create, your constructor is called, you'll call point list is equal to new array list point, and then you create your array list that is going to keep points in it. So each point is a point object which has the x coordinate and y coordinate. Okay. And then what do? I have the add mouse listener dots listener. So this is basically the mouse listener event, which is going to listen to this mouse event, and then whenever it happens, it will call this object to perform the corresponding action. And then I set the background and set the size to the given specific size. Now next what I do, I have the paint component, and then it paints the panel's first properties on the screen, and then after that I set the color to green so that I will have the green dots on the screen. Then what do? I have the point list array list. Remember, this was an array list that is composed of points. So each variable will be a point. That's why my spot variable is type point. So page fill oval. This is basically the fill oval component that you know from before. And then I have the x size and y size, and then I have the size times 2 and then size times 2 to indicate the specific points, location with the coordinates that it have. And then page draw string will paint the string that is going to tell you the current number of points in the array list, which is going to be captured by point list dot size. It will go into the coordinates x and y 5 by 15. Okay, so basically what we do here is that this is the for loop that paints everything over and over once you click one more additional point. Okay, so basically I call the paint component in order to repaint everything. That's where this happens actually. So mouse pressed event, coming back to the dots listener, implements mouse listener. This was the interface again, if you remember. So I'm implementing this mouse listener, which has all those methods that we mentioned. One of the methods is mouse pressed, and the other methods are mouse clicked, mouse released, mouse entered, and mouse exited. So none of these are implemented. However, I need to list them since I'm implementing the whole interface. Okay? I say that I implement this interface, in which case I need to implement all the methods. However, if you don't have anything special for this event, you'll just leave it as empty as given here. I'm only considering the mouse click, so I use the mouse pressed event. And then once this mouse is pressed, I will add point list add event get point. So this will give me a point type of point wherever this mouse click happened. And with get point, that will give you the two dimensions x and y. And I will use that point to add it to my point list. So once I add this point to my point list, what do? I call the repaint method so that it's going to go over back to this paint component and recall everything from scratch. So it will call the panel, paint it on the screen, and then the new list will be painted one after the other one. Okay? So this is basically how this is going to be implemented. However, if you happen to add more things such as mouse click, whenever the mouse click event happens, you would like to do something based on that. You can add that event and whatever you want to do in the brackets here. Or you have mouse entered event that you would like to perform with the mouse entered, and in that case you can just write whatever you need to write there too. So it's basically an interface which has 5 methods, you have to write all of them, but you don't have to implement all of them at the same time. If your listener implements two, again, such as mouse listener and then mouse motion listener, then you will have these 5 methods. On top of that, you will have those 3 methods or 2 methods, whatever those are, on top of these 5 methods, so that at the end, you will have all the methods implemented in your interfaces. So this is the example. So rubber banding, again, it's related to a mouse event. It's a visual effect in which a shape is stretched as it's drawn using the mouse, so you can stretch it as you go. So if you look into the rubber lines example, you'll see that it's also an interesting application. Rubber lines, Java, and then so let me execute this. So this is the screen. So whenever I move my mouse while it's dragged, actually, it paints this line on the screen. And then whenever I have this one, for example, so it basically, so how does it do? How do you think I'm implementing this? I click first, and then I'm still moving my mouse. So it's happening while mouse is actually on the move. So it must be a movement that is associated with it. What kind of movement? Motion. What kind of motion? Dragged, right? So I'm dragging the mouse and then leaving it some other location and then restart it again. So this is basically involving dragging. So we will see the details after the break. So let's give a break now and we'll continue.